Hello, my name is Theophilus Gibson, and today we will be doing a spectrometer demonstration, and my group mates will be explaining concepts and aspects of the demonstration today.
Molar absorptivity can be determined via the Beer-Lambert law, where absorbance equals molar absorptivity times path length times concentration. We find it by dividing absorbance by both path length and concentration. By doing so, we would have molar absorptivity on one end and all the other variables on the other end. And if we have all the other variables on one end and known calculations for all the other variables, we can determine the molar absorptivity. Absorbance is determined via the spectrophotometer, where we put the cuvette that has the solution in, and we put in a specific wavelength, and that specific wavelength is typically the maximum absorbance the cuvette will make, or the solution will make. We put the cuvette into the spectrophotometer and it will output a specific absorbance. Path length is determined via how much distance the light goes, and it is usually fixed at 1 centimeter in most laboratory settings. And in our situation, it would be the length of the cuvette. Concentration is determined via preparing a series of standard solutions with known concentrations, and then performing a series of dilutions with the known concentration using the equation M1V1 equals.
Quantitative data from a spectrophotometer is numerical, like absorbance values that can be used to calculate concentration, while qualitative data is more descriptive, like the color of the solution or which wavelengths are absorbed. We scan across all wavelengths for a few reasons: to find the wavelength where the substance absorbs the most light, and to see the full absorption pattern, which helps check for impurities. The scan creates a graph of absorbance versus wavelength. The lambda max is the wavelength where the absorbance is highest, which gives the most accurate results when calculating for concentration.
Absorbance is how much light a solution absorbs at a specific wavelength. Molar absorptivity is a constant that indicates how strongly a substance absorbs light at a particular wavelength. Path length is the distance that light travels through the solution. And concentration refers to the amount of the absorbing species in the solution. The Beer-Lambert law is absorbance equal molar absorptivity times path length times concentration. Absorbance is directly proportional to the concentration of a solution, according to the Beer-Lambert law, where if there is more absorbance, there is more concentration. And if there's more concentration, there is more absorbance. Failing to zero the machine would affect the absorbance value by creating an overestimation of the absorbance value. It is because the spectrophotometer is not properly calibrated, resulting in the absorbance reading, including the absorbance of the solvent and the cuvette, not just the solute. Molar absorptivity can be determined via the Beer-Lambert law, where absorbance equals molar absorptivity times path length times concentration. We find it by dividing absorbance by both path length and concentration. By doing so, we would have molar absorptivity on one end and all the other variables on the other end. And if we have all the other variables on one end and known calculations for all the other variables, we can determine the molar absorptivity.